Hey folks, welcome back for another episode of Code Club. The previous two episodes, I spent a lot of time recreating a figure from this paper from Applied and Environmental Microbiology titled Strategies for Effective High-Pressure Germination or Inactivation of Bacillus Spores Involving Nisin. What that means, you don't need to know. Basically, these authors had a bunch of different treatments where they were trying to kill this certain type of bacterium called bacillus. If you wonder why that's important, well, anthrax is caused by an organism called Bacillus anthracis. Anyway, if you scroll down in this paper, and if you want to get this paper down below in the description of this episode, you will find a link to the paper. And we get to figure 5 here. This was the figure that we made in the previous episode. And as you saw, I could make this figure in ggplot2. It took a fair amount of tinkering. Here are the 3 versions of the figure. The one on the left is the version from the paper. The one in the middle is one that I made without any hashing. And the one on the right is one of the versions that I made with hashing using pure ggplot2. There was a fair number of things that I did in these episodes that I would say is ggplot2 perhaps at a higher level, a bit more of advanced concepts. So what I want to do today is take a step back, kind of approach things, I don't want to say at a beginner level, but perhaps at a less advanced level, right? Using things more from, say, dplyr, and also using more commonly used and widely seen functions from ggplot2. And I want to show you how we can use those, I don't want to say simple, but more simple tools and still make a publication quality figure that I think is actually going to be better than what we see in this visual, to be honest. Some of the things that I would critique in this figure would include, first of all, the hashing, right? Like, I don't think these lines are really necessary. Second, I do not like having axis labels that are units, right? Or are formulas like this. Like, tell me what this is, right? This is the log killing of bacillus by these different treatments, right? So it's not super descriptive what's going on. It's a bit jargony. And I would prefer it to be perhaps a bit more clear what's going on. And so I would prefer perhaps not to have the log 10 transformation of the data. And perhaps what we could instead have would be the 10 to the minus whatever the value is here, right? And also what we might prefer is to not have a bar plot. What would it look like if we didn't have a bar plot? What if for each of these values, the mean, we represented with a plotting symbol of a different color, and we added to that the error bar, right? And so that's kind of the approach that I want to take to this plot in today's episode. And a lot of time was spent in the first of this series of episodes in getting this legend to be in the bottom corner here. So we'll see if we can perhaps take a simpler approach to placing the legend, all right? So again, heading to RStudio, if you want to get the code for this episode, as well as the link to the original paper, and a link to a newsletter article that I wrote about this visual, down below in the description, you'll find all those links and encourage you to go check them out. This is the simulated code that I am going to be starting with. I do set a random number generator seed, 1976-0620, it's my birthday, because we are generating simulated data using our norm. So this will give us a data frame called spore data, and we can see that it's got 24 rows, 3 columns, right? So we have the fraction alive, the heat treatment, whether it's before or after, and then A, B, C, or D. And those are the 4 treatments across the x-axis, right? And so again, let's turn back to our code. And what we'd like to do is to summarize our data by each of the 4 treatment groups and each of the heat treatments. And so we could take spore data, we could then do group by, and we could then do group by heat and treatment, and then pipe that to summarize. And we'll then get a mean alive, and that will then be mean on fraction alive. And then we'll also do SD alive, and that'll be SD fraction alive. And that then gets us this tibble with 8 rows in it, right? We have the after heat, before heat, and then ABCD, the mean alive, and the standard deviation. It's still being grouped. We can remove that grouping by doing .groups equals drop. that removes the grouping entirely, right? And this is the data that is now summarized that we can then plot using whatever geom we want. This series of steps, this chunk of code was done in the previous episodes using the stat summary functions, right? And so again, that's a bit of a more bigger lift to use. It's actually not something that I'm super familiar with myself. I've only started using it kind of in my own ggplot journey, but we'll call this spore summary. And then we can take spore summary and we can then pipe that into ggplot. We actually don't even need to store this as spore summary. Maybe I'll go ahead and maybe I'll actually do that. Well, I'll pipe from this pipeline directly into ggplot. So we'll do ggplot and then AES. On the x-axis then, we're going to have at this point, we're going to have the treatment. And on the y-axis, we're going to have mean alive. And then we'll also have color, and we'll make that heat. And then let's try doing geom_point. And what we see, again, this is the mean alive, that only about 10 to 20% of the cells remained. And then these seem very small because these are actually on a log scale, right? That we saw kind of that log fold reduction. If we wanted to see that log fold reduction a little bit better, we could do scale y log 10. So now we see 10 to the minus 1, minus 3, minus 5, minus 7, right? So now we want to take it up and make it look a bit more like a publication quality figure. So the first thing that I always like to do to take a plot from looking like it belongs in a lab meeting to something that looks like it's ready to be published is to add theme classic. This will get rid of that gray background, those ugly grid lines, and gives us solid axes. And solid axes just make me feel grounded. I don't know why. Anyway, I think this looks clean. And again, your mileage may vary, and it's always a good kind of place to start as we're building and improving the appearance of our figures. So what I'd like to do now is go through each of our three aesthetics. We have heat for the color, treatment for the x-axis, and mean alive on the y-axis. So let's start with the heat. So the first thing I notice, and we saw this before, was that the order is not the order that makes sense for the experiment. We have after and then before. Before comes before after, right? Not after. Anyway, so we need to change this order. And we can do that using what's called a factor. And a factor in R is ordinal data. It's a categorical variable that has some type of order to it. By default, R will assign the order to be alphabetical, as we see here. So we can modify this by doing mutate, and then we'll modify heat to be a factor, and we'll do heat as the column that we're going to turn into a factor. And then we can set the levels to be a vector containing the order that we want, right? So we'll do before heat, and then after heat. And we'll go ahead and pipe that into everything else. And now we should see the order of those two variables flipped. Sure enough, we now have before heat and after heat. I don't tend to like having titles on legends, especially if there's only one legend. It's kind of obvious what it's for. So to remove that, so let's come into our code and we can do labs color equals null. And so that then removes that title from our legend. Let's leave the colors there for now. We might want to change the colors later, but hey, these are the default colors. You don't really have to do a whole lot to change them. The next thing that we could do, again, is think about our x-axis. And so here we have A, B, C, and D, and we can set those labels using scale x discrete like I have in the two previous episodes, or again, we can use a factor. And so I'm going to come back up to this mutate statement and then do treatment equals factor, treatment as what's becoming the factor. And then instead of levels, we'll do labels, right? And so labels is appropriate because a factor is effectively a numeric vector that has labels put onto those values, all right? And so I'm gonna leave you here for a split second while I go away and come back, because I'm gonna copy and paste those labels so that you don't have to watch me slog through all the typing and my typos. All right, so we get that in. Let's go ahead and run this and see what it looks like. And now we have our labels on the x-axis. Another thing I don't like about labels is having labels for a categorical axis. So it's clear that these are the different treatments that were applied. even if they're pretty jargony and it's kind of hard to understand what was going on. And so let's go ahead and remove that treatment label. So here in labs, we can do x equals null. That gets rid of that treatment label. So now I'd like to turn our attention to the y-axis. Something that is missing would be 1, right? So that would be basically the level where there was no killing. So I'd like to include that. We also don't have the limit of detection, which was 10 to the minus 8. So let's go ahead in here then and do limits, and we'll give it a vector from 1e to the minus 9 up to 1. And so that bumps it up, but we don't see anything here, right? And so we need to add the breaks. And so we'll do breaks. So the breaks are going to be where we want to show a value on the y-axis. So we'll start at 1, and 1 is 1e to the 0, right? So that's 1. And then I'll go down in 100-fold increments. So we'll do 1e minus 2, 1e to the minus 4, 1e to the minus 6, 1e to the minus 8. So I think this gives us a pretty good interval rather than having all of the data present. We can also make our labels look a bit more attractive on that y-axis. So we can do labels, and again, we'll do C. We can do 10, and we'll again do sup 0, and then / sup. And so what this is going to do is this can give us 10 to the 0, right? So basically 1, right? And this is HTML. And that's really all the HTML you're going to need is this for sup and perhaps sub for subscript. So I'm going to go ahead then and copy this, and we'll go ahead and put in the minus 2, and then we'll do the other values as well. The minus 4, and then minus 6, and then minus 8. And it's complaining about something. Oh, these all need to be in quotes. All right, so those need to be in quotes because they're strings, right? This is HTML code effectively. All right, and I'll go ahead and put this on a separate line so it doesn't roll over. And we'll get these final two in quotes as well. And so again, quotes are useful whenever we are representing strings. So now when we run that, we get our HTML out into the left column, right? But we can add another package, library ggtext. And I love ggtext because it allows us to use HTML like this to make superscripts and subscripts. And so this might seem a little bit scary, but trust me, it is a lot easier than the alternative. So here then we can add theme, and what we can then do would be to do axis.text.y equals element markdown. And my pop-up thing is in the way. Element markdown. And markdown is kind of like HTML in a way that allows us to style the appearance of text. And so now what we see is that sure enough, we have our superscripts. Now what we want to do is add a y label or y title. And so here then we'll do y equals fraction of, I'm going to put in here bacillus remaining. But bacillus is a bacterial name. It's a Latin name, and it should be italicized, right? And so what we could do, I think, would be to do an I tag. And again, that's HTML. And here again, we can do axis.title.y equals element markdown. And so that then italicizes bacillus, but leaves everything else as a normal font. Again, there's just a little bit of styling helps you to give your figure just a little bit more polished. So if we wanted to put italics for a single word or any of the labels on the x-axis or for the title, we could also do axis text X and axis title X, right? And so again, these are ways to just kind of gently dip your toes into the waters of modifying the theme argument, okay? Let's turn back to what we're actually plotting though, right? And so in here we have geom point, and these points are right on top of each other. And down here at 10 to the minus 8, you really can't see the data, right? And so what we could do would be to say position equals position dodge. And it's going to complain because it wants a width argument, right? So in position dodge, we need to give it a width. And so let's do 0.25. And so now we see that that pulls those 2 points apart a little bit. And let's go ahead and pull them apart a little bit more. Let's do 0.5. And I'm going to make those points a bit bigger, right? And so in here then I can do size equals 2. All right, let's make them 3 just to make them big and chunky. There's not a lot else going on in this figure, so I don't mind making them bigger like that. And that looks good. We're also missing our error bars, right? And so in here then, before geom point, I'm going to put geom error bar. And I'm going to put it before geom point because I want the error bar to show up underneath the plotting symbol. So to put the error bars in, we need 2 additional aesthetics. We need a y min and a y max, okay? And so for y min, we're going to give mean alive minus SD alive, and then y max will do mean alive plus SD alive. And so we add a plus sign to this. So now we see that we sure enough have our error bar, but it's also not being dodged. It's a lot like what we had for geom point originally. And so I'm going to go ahead and grab this position equals position dodge and throw that in. So we see kind of funny looking error bars. They're not symmetric because we're dealing with this kind of funny log scale on the y-axis, right? But that's correct. But the error bars themselves are wider than the points. So we could come back to our geom error bar, and then in here we could add width. And so there's width in position dodge. That's basically how much should we separate the points from each other. And the width is going to be the width of the staple or the top of that error bar. So here let's do 0.2. And so that gives us a more narrow error bar. I'm going to suggest maybe we go up to say 0.3. That looks good. So I'm going to go ahead and save this plot now to a file. When you're making publication quality figures, the publication, the journal, will tell you how big the figures can be. And so I always like to use those dimensions to specify the size of my figure, because when I start moving things around, like I'm going to move that legend here in a minute, when I start moving things around, then the plotting window in the bottom right corner here of RStudio doesn't serve me very well, let's just say. So I'll say ggSave, so I'll say fraction alive, and my width, let's go ahead and make it 4, our height, let's make that 4 also. We'll start from there. Oh, and I didn't give it an extension, and so we need to do .png. ggSave figures out what format to save the file as based on the extension you give it. And so this is what our plot looks like, okay? So that's great. I want to, again, move our legend maybe into the upper right corner of the plot because it's using a ton of white space over here. And I kind of think that like if we had more space on the x-axis, then maybe we could write out what these names are a little bit better. This is going to require us to go back into the theme function. And so here then we'll do legend.position equals inside. And that's going to tell theme to put the legend inside the plot. We'll then do legend.position inside. And now we're going to give it a vector of 2 values, x and y. And I think it's basically where it's going to center the legend in our plot. So let's start with 0.75 and 0.75. That's then centered it right about 0.75, 0.75, and given more space on the x-axis where we perhaps have better separation of the different groupings, that we could perhaps write out what this jargon means, right? I'm maybe going to lift it up a little bit. And so again, the first is the x and the second is y. Let's put this at 0.9, and that puts it up at the top. One challenge with putting a legend inside of the plot is that users might get confused about, well, is this data, right? And so we can draw a box around that legend. And so we could then do legend.box.background. I always get confused between legend box background and legend background. So let's try both. And this will take another function called element rect. And so these element rect or element markdown are ways that we can assign values to these different elements to get the desired appearance. And so for this, we can do color equals black. And sure enough, we now get our black border around our legend. I'm curious what happens if we do legend background equals element rect. That actually gives us a stronger border around our legend. So I'm cool with that. So 2 things stand out to me about this legend that I want to resolve. So the first is that I prefer to have the first character in the legend title or legend text be capitalized. So I'd like that before and after to be capitalized. The other is that I've got the horizontal line going through the plotting symbol. So let's go ahead and change the label first. And so we've seen this actually, right? That we can do that. We can change the label here in where we define the factor, right? And so I'm going to copy this levels down. So instead of levels, what do we want? We want labels, right? And so then I can make that a capital B and that a capital A. We have that capitalized letter, and I think that looks a bit more professional. Now, I also mentioned this horizontal line through the plotting symbol, and that is coming again from the error bar. And I don't know that we need that horizontal line. I feel like it kind of just, it just makes the plot a little bit more busy. And so I'd like to remove that. And so the way we can remove that actually is back up here in geom error bar. And the argument that we can use is show.legend equals false. And so we have two geoms. We have error bar and point. And as long as we leave the legend on for geom point, then we'll have a legend. But if we show legend false on the error bar, we'll get rid of that horizontal line. And so now, sure enough, we have the error bar still, but we don't have the horizontal line for the legend. And of course, if we had done this with geom point rather than geom error bar, let me show you what we'd get. What do you think we'd get? Well, we'd have a legend without the circle, but we'd have the line. There you go, we have the line, but that doesn't make sense, right? So I'm gonna go ahead and put back what we had with removing the legend for the error bar, and we've got our nice circles. Now, this legend seems to have a fair bit amount of space around it. I'm not totally a fan of that. So we can come back down into our theme function, and doing more and more stuff in the theme is making our plot a bit more and more complicated to understand what's going on. Usually what I do, and the way I've learned a lot of this stuff about the theme function, is I'll say, you know, I look at this and I don't like the border, the margin, or the space around my my text in the legend. And I Google that, right? Like how to reduce the space around labels in legend ggplot2. And that will generally get me to something that kind of shows me how to use the theme function to do that, right? And so you kind of have to do a lot of this to get kind of a mental model for how the theme function works and what ggplot is doing. So, and be willing to make mistakes. And I might make mistakes here as you watch me, right? So we could do legend.margin. That'll take the margin function. And let's give it all zeros. So the way margin works is that you give it a value for the top, the right, the bottom, the left. Trouble, right? That's how you remember it. And so now we see a pretty tight margin, and there's something kind of funky going on here. I think our plotting symbols have their own space around them that's bleeding in to the border, right? So why don't we go ahead and shrink the plotting symbol size? That's called the key. And so we can do legend.key.size, and this will take a unit function. And so here, let's go ahead and do like 12. And I need an equal sign here, of course, and I need a units. So let's go ahead and give it points. And so that did a couple things, right? That reduced the amount of space around everything, and it actually brought the two labels together. And so let's maybe reduce it a little bit more. What happens if we go down to say 10? All right, so I think that's good. Now let's put a little bit of margin back in, right? I think that's nice and compact, but we do want a bit of space around the whole thing between our text and our key and the border. So let's come back to our legend margin, and let's do 3 all the way across. And there you go. I think that is pretty attractive and looks pretty good. So really at this point, even before all the stuff I had done with the legend, I think this plot would have been pretty close to being ready to publish, right? To include as a publication. There's a few more things that I would like to do. One would be to show the limit of detection line at 10 to the -8. And maybe you would like to put in horizontal grid lines, right? So maybe some grid lines are good, but not too many, right? So to add in that limit of detection line, we can come back up here to after the geom point and do geom hline. The argument that's going to take is y-intercept, and that's going to be 1e to the -8. And so now we get a solid line at 10 to the -8. And actually, I have that after geom point, and I probably want that to go before everything. I want that to sit in the background. You can kind of think the order of things here as being kind of the layer that it sits on with the rest of the figure. And so let's make the color to be gray. I like to have it be gray again because that limit of detection line should just kind of like be there, but be pretty subtle. We also want to make it a little bit thinner. And so we'll do line width. And let's do 0.25. I think the default is 0.5. So that gets us a more thin line. We can also make it dashed, right? So we can then do line type equals dashed. And that gets us a dashed line. I don't know if I'd prefer dashed or solid. You do what you think is good. But I think that's pretty nice. One thing I noticed or have been noticing is that with Theme Classic, the X and Y labels get a gray color. They're not solid black. So in axis text Y, within element markdown, you could do color equals black, and then axis.text.x equals element text, color equals black. And so now our font is black, a bit stronger color than what we had previously. One of the things I mentioned about making the plot wider is that we might now have more room for writing out more of what's going on. And so we could imagine coming back up here and doing like Valine, wherever we had Val, right? And then Nissen for wherever there's a Nis, right? That \n is a line break. And so now we can see that Valine, Nissen, like it doesn't cost us anything to write out the whole thing, right? So there's no HP, will be no pressure, whereas this MHP will be moderate pressure. And then this will be very high pressure. And I guess I'm leaving pressure to be lowercase. And then here we'll also have very high pressure, right? And so then we'll put that here. And there's actually another VHP over here. That pressure isn't working very well, but you know what? We could very easily put in the actual pressure. And the actual pressure for moderate pressure was 150 megapascals, and for very high pressure it was 550 megapascals. So we could put in like something more specific, right? So this could be like, I think it was 150 MPa, and then 550 MPa, and we can replace this also. So even I think writing out those labels, I think was pretty effective in making the plot a bit easier to understand. I don't know. You tell me what you think. So the final thing I want to do is to differentiate your plot from every other plot that is made with ggplot2, and that is change the colors. These colors are the default colors, and if you can change these colors, then I can't tell you how much higher prestige people will have you for your ggplot2 skills because you're not using the defaults. And it's not that hard to change. So we'll use scale color manual, and then in here we'll put values, and we'll put in two colors that we like. I'll do Dodger blue and then dark red. I'm thinking blue and red because it's like cold and hot. The figure legend said that they stored samples on ice, which makes me think of cold, which makes me think of blue. Dark red makes me think of a heat treatment that makes me feel warm, right? So that's my logic for using those two colors. And so now what we see is that we've got a blue for before heat and the dark red for after the heat. So I think this figure looks great. Something you might think about doing would be to add horizontal grid lines. I'm not going to worry about that. You can do that also within the theme function. You can use your Google skills to say, how can I add horizontal grid lines in ggplot2, and see if you can't figure that out. But again, I think this is an attractive figure. It's relatively simple to the eye. It doesn't have all that extra stuff going on with those bars. I think it has better labels on the Y and X axis. It's more clear what's going on with these values on the Y axis. And overall, I'm biased, of course, because it's mine, but I like this. If the authors of this paper ever see this figure, please let me know. What do you think of my version versus yours? Of course, when we're making data visuals, there's all sorts of constraints that we're up against. Constraints in the data, constraints in the story, how the experiment was done, but also the constraint of like what we know how to do. So I don't know what software the original authors used to make their figure. I don't think it was ggplot2. There's enough things that are pretty different, especially that hashing. What we know how to do will definitely limit and shape how we represent the data. And so that's why it's good that you're watching videos like this to always be learning and try to do something more. I hope you enjoyed this approach. I did try to keep things simple without being too basic or too elementary. As you'll see, nothing is like elementary in this, right? Like there is nothing that is overly simple, but none of this stuff is really beyond a lot of kind of the basic concepts of using things like dplyr and ggplot2. And if you keep practicing with it, take this code, adapt it for your own question, take this code and modify it to do something else, I think you'll really learn a lot. As you keep watching these videos, I hope you continue to learn more and more about how you can use ggplot2 to make really attractive visuals that you can use for papers, for presentations, for posters, for whatever. Anyway, let me know what you think down below in the comments of this episode. I hope you're telling your friends about what we're doing here on Code Club, and I look forward to seeing you next time for another episode of Code Club.